Hello everyone and welcome to another Directions Mag webinar. Today sponsored by our friends at Nearmap. I'm Barbara Duke, Managing Editor here at Directions Magazine, joined by our webinar producer Lynette Qualia. We encourage you to stop by directionsmag.com for feature articles, daily news, podcasts, and of course more webinars. We are excited to have Tim Lyons with us today to talk about creating photogrammetric 3D vector buildings and learning more about imagery. Very cool stuff that he has got to show us today. Tim, welcome. We're glad to have you with us and excited to learn more. Over to you.
Thank you very much. Looking forward to diving in. My name is Tim Lyons. I'm a solution engineer here within the government vertical over at Nearmap. Mainly work with municipalities of various sizes, everything from local to state level agencies. Also spend some time working within the commercial customers here at Nearmap, so primarily the engineering utility focused use cases. As I mentioned, I'm really looking forward to diving into today's topic and showcasing some of the cool things we're doing here at Nearmap. I've been with the company for a little over a year and a half now, and it seems as it's every quarter we're releasing a new product or improving the products that we have. And thankfully, as on the SE team, I get to play with that pretty much all day, so no complaints. Today we'll be going through the creation of 3D vector buildings and how this photogrammetrically derived piece of content can deliver various benefits across any industry. So a little bit of history of Nearmap. Established in 2007, headquartered in Sydney, Australia. We came over to the US in 2014. We are a cloud-based subscription model set up as a software as a service. 100,000 users across the globe and over 1 million square miles of sub 3-inch imagery captured annually. Kind of the journey from 07 to today, again, established in 2007. Started capturing in Australia, switched to a SaaS model. We came out with our first hypercamera system and then made the jump into the US market. After 2016, we started in New Zealand, came out with our second hypercamera system, which we'll talk about here soon, which launched our capabilities to do oblique and 3D capture. 2019, extended capture to Canada, and then developed some roof geometry technology, launched our AI products, launcher impact response, and hypercamera 3 is soon to be coming in 2023, hopefully. So as you can see, just on this timeline, it feels like every other year, every other couple of years, something new and exciting is happening at Nearmap. So we do a wide scale 2.2 inch to 3-inch coverage. So it kind of has the population breakdown here through each market. So you have the Australia, New Zealand, US, in Canada. You can see that Australia is the largest that we cover, with US population-wise sitting in second, New Zealand, and then Canada after that. So the three, I would say, groups that imagery is going to fall into that I'm sure some of you are using on the daily data basis, but for those that are new to the realm of imagery capture, these are 3 buckets that we're going to fall into. So you have your satellite imagery. That's going to be your lower resolution. That's anything from 30 centimeters all the way to over 3 meters in accuracy. And then you have, obviously, it's a global scale, best suited for macro environmental analysis. Obviously, with the satellites that we have, I mean, I'm sure there's many that we know about and many that we don't, with capabilities that stretch into the multi-spectrum, and they can do some interesting things with the analysis out of those camera systems. The aerial aspect is what Nearmap falls into. We're an aerial imagery company, so we use airplanes to capture our imagery. We're sitting at in this group, average resolution is going to be 5 to 30 centimeters. It's a region-wide scale, frequently updated, multiple high-res, ortho, oblique 3D, and fine detail and feature extraction. And then the last but not least would be that drone capability, sub-centimeter resolution. Project-based captures, obviously, it's one person going out with a drone, covering a relatively smaller area, very different from satellite or aerial captures. Can be expensive, time-consuming to coordinate, but you can get probably the highest accuracy out of the drone capabilities, absolutely. So Nearmap in our product stack, we capture our vertical imagery. As we mentioned before, that is a sub 3-inch resolution. That's going to range from that 2.2 to that 2.8 inch GSD. We have panoramas. So that's that fixed 45-degree angle, and you have the ability to maneuver around that scene at all cardinal directions. And then we have an oblique view, which you are allowed to go in and actually look at those source tiles, look at different vintages of prior years, as well as still pan around the source tile, make any measurements, make any markups, and change between the cardinal directions. Our Nearmap 3D, and I'll go into the products that we have after that, but we create a Nearmap 3D through photogrammetry. We stitch everything together and create that textured mesh, that tin model, and then that kind of kicks off all of our 3D products that come out after that. And then Nearmap AI, we run all of our imagery, all of our vertical imagery through machine learning, and we essentially do feature extraction on all of our imagery, and we'll touch on that here in a little bit. And last but not least is Nearmap Impact Response, and that is our post-disaster, post-catastrophe capture program, where days or even hours sometimes after a flooding event, hurricane, wildfire, tornado, etc., throughout the U.S., we'll go out and capture high-resolution imagery and get that back to the clients within days. Back to that 3D component, the first thing is our textured mesh. It is that wireframe lattice with that high-resolution imagery draped over the top of that. It sits at a 6-inch resolution. From that, we create a point cloud, a digital surface model, which we'll be using today in the demonstration, the digital elevation model, we'll be using that as well, and our true ortho product. As for Nearmap AI and the feature extraction, anything from swimming pools down to construction sites, vegetation, impervious surfaces, we have these raster, and then we also vectorize these components. We'll be actually going through the building footprints today in the demonstration. Trusted and loved by thousands of users. Just to name a couple here, City of Sioux Falls was thankful enough to actually put us up on the planetary at the ESRI UC, which was showcasing our textured mesh, which was awesome to see. So shout out to them. Stantec is a proud user, Cardno, big user out in Australia, and many more to name. Growing partner ecosystem. We're gold partners with ESRI, so integration components are pretty seamless. So we have multiple different avenues you can go through. Autodesk, we work swimmingly in there, and then recently just partnering with Tyler Technologies and other popular components such as CityWorks, Cesium, Carosoft, and GSA. So accessing Nearmap application intelligence, we have our own map browser is what we call it. It's our lightweight web application. It stores all of our imagery, so everything from a vertical down to our 3D products and our AI. It has all of our historical imagery that each customer has access to. So in the US, dating back to 2014, you can go back all the way to those dates, do site comparisons, etc. We have ESRI marketplace items that you can bring in through ArcGIS Online, bring it into ArcMap, bring it into Portal, and then we also have REST APIs that you can ping, and tile APIs, coverage APIs, numerous forms of integrations into the third-party applications you're using, and that's including our 3D. You can download our 3D and bring it into, say, Civil 3D, Bentley, Open Roads, etc. So I know all of you are thinking, okay, Tim, everything sounds great, but let's get into the 3D vector buildings, and I agree. Let's start diving into what everybody signed up to be here for today. So first off, what is a 3D vector building? So thanks to Nearmap's artificial intelligence, we started off by creating 2D raster feature extractions from our imagery. For the government space, what I work in primarily, definitely one of the most used are our building footprints. The next step was to vectorize these footprints and provide metadata to each footprint, quantitative data such as square footage, building heights, story count, etc. So Nearmap has a diverse product stack, and leveraging our AI with our 3D, we can now enhance those visualizations and the quantitative data of the 2D building, showcasing it within a 3D environment. So some of the use cases that we're going to be able to pull out of this demonstration today is viewshed analysis, line of sight for telco industries and public safety aspects, remote site inspection, and assessment for construction use cases, and also assessors, a large primary use case throughout the country. Analysis and modeling. I do have a flood model example that I can't wait to show you guys at the back end of this, based off some of the things that we're going to show today. Urban mobility, urban planning, and the list definitely goes on. I'm sure there's plenty of people here that will watch this webinar and then be able to make up their own use case and see how it can fit into their own workflow. But in my opinion, the overarching benefit of having accurate 3D building environment, it's going to bridge the gap between the 2D and the 3D environment, making remote work, design modeling, and numerous deliverables just that much more accurate and reliable. So the content that we're going to use today is our vertical imagery. We're going to be using our digital surface model, so our DSM is what we'll call it. So that is that 3D elevation raster that we will be looking at, and that is going to pick up elevation values. Each pixel in that geotiff, that raster image, is picking up an elevation value of all the artifacts on the Earth's surface. So we'll have our tree canopies, we'll have our buildings, bridges, infrastructure going to be in that scenario. The next portion of that is our DEM, otherwise known as our DTM. It's that digital elevation model. So that's that bare Earth scenario. So that's all of the artifacts that are above the Earth's surface removed. So you just get that bare Earth elevation. And then last but not least will be our AI building footprints. So before we kick off the demo, just to kind of set the stage and get everybody in the right headspace of what we're trying to accomplish. So picture yourself as a GIS analyst for an appraisal department. And you've been asked to take the existing building footprints you have on site, and let's say you're looking at a local subdivision, and turn them into 3D models with accurate heights and correctly shaped roofs. Additionally, each building is required to have attribution that records the building heights and roof characteristics. Not only is 3D attribute information valuable for appraisers, obviously they want to know what type of roof material it is, what type of hip slope, whether it's a hip or a gable or flat, etc. But this use case can be used for a variety of use cases across government, enterprise, and emergency management, obviously facility management, planning, and then building information, so BIM. We'll be utilizing ESRI's 3D base maps. So first thing first, we're going to take a look at the information that we pulled in here. So we have our AI building footprints, our digital surface model, and our DTM. Last but not least, I'll go ahead and turn on our marketplace item through ESRI, Nearmap US vertical imagery, to give us that backdrop. So I'll zoom into the layers here, and you can see how accurate those line up with the buildings underneath on the imagery. They are vectorized 2D rasters, so we'll go ahead and click on these and see the metadata behind. So we have our confidence score, our area, building height, story count, fidelity scores as well. The next component will be our DSM. So you can see here, it's picking up the tree canopies in here. That'll actually go and turn on the AI building footprints, and you can see how the outlines will be shown in the DSM, and they still line up with the AI building footprints pretty accurately. Next is that DTM. You can see that riverbed that's coursing down the side on the right-hand side, and that is your bare Earth scenario. And just for bookkeeping purposes, I'll go ahead and rename this to building footprints before we dive in. All right, so the first step is we'll need to create a NDSM, or a normalized digital surface model. So using raster functions, an NDSM is created when a DTM is subtracted from a DSM. The result is an elevation raster that represents the ground level elevations of features as well as their height. So we'll go ahead in here and change the symbology just to give a little better context to the surrounding area. And you can think of that DSM is that absolute ground level height. So if you were to go out to your driveway, measure to the top of your roof, you would want that measurement to say it's 40 feet rather than 385 feet, which depicts the elevation. Again, those building footprints are still lining up nicely with the rest of the data in here. All right, so the next component will actually be to process the building footprints. So to begin working with the building footprints, you'll use the provided task steps to clip the DSM raster to each building footprint. Then the elevation will be used to segment the roof, which means that each building footprint will be subdivided based on which way the different parts of the roof are facing. So this is going to help us give us that roof characteristics as defined hips and gables. And the last component will be to create 3D buildings. So now that we have the DSM and the segmented building footprints, you're ready to make the 3D models. And as we're going through, you'll be able to see those 3D vector containers be published after this runs. And we're just using the default settings that come up in the create buildings tasks. All right, so I'll zoom in here, and I'm in a ArcGIS Pro local scene, so I'll be able to rotate this 3D environment. And then you can see how those 2D building footprints are still sitting up on top of those buildings. And I'll go ahead and turn on the vector containers that we just created. And now you can see those buildings have been extruded. So we'll go ahead and rotate the scene. You can see how the roof characteristics, and we have some hips and gables, are going to be up on top of these buildings now. I'll go ahead and change the symbology here shortly, probably to the ugliest color that you would put on the siding of a house. But the gray roof, I would say, corresponds well to what you would see naturally in a neighborhood. Again, I'll go ahead and click on one of these containers, and I'll scroll down to the bottom, and you'll see that our building height, our eave height, roof form, and base elevation are all imposed into this attribute table. So as you can see, that this process worked for a whole entire building footprint stack. So there could be anywhere upward 30 buildings in here that we were able to update pretty seamlessly, just in a couple steps, thanks to the 3D base maps component. Now, if you have your own building footprint fabric, if you have your own elevation data, you can actually go ahead and do this through the 3D base maps. It doesn't have to be the Nearmap data. And what I'm doing right now is actually fusing then to actually be a 3D feature class. So right now, essentially, these are just 2D features with 3D symbology. So the operation of fuse is actually going in and updating that from a 2D to a 3D feature class. And you can see within the database, it is indeed part of the file database as a 3D feature. As I rotate the scene, you can see definitely there's some big houses. I believe this is in California, in Pleasanton. And yeah, this is the end product that you're going to be able to move around, add any building information to this outside of the the attribute table that we have. This is just the stock information that comes with our building footprints, but you can add more information to this for your own data set or purposes. So we'll go into this next model, and this is that flood model. So going into the use cases and what this can actually be used for outside of the appraisal district. So flood modeling, resiliency building for communities is definitely a big component with natural disasters such as flooding. So what we did here, I believe this is in Kansas City along the river down there, and we went in, made our building models, and what we refer to at Nearmap, they're called LOD2s, so level of detail 2. It's a very simple metric. You have 0 to 3. 0 would just be the least amount of detail. It'd be that 2D raster image that's sitting flat on the surface. LOD1 would essentially just be an extruded block with no other roof geometry tied to it. LOD2, what you're seeing here, it is extruded correctly to the correct height, and it has the roof attributes associated with it. And then LOD3 finally would be the most detail, and that would have things such as surfaces on like windows and doors, etc. So I'll go ahead and play this, and I used the FEMA layer. I was able to pull out of their organization. I also pulled our AI extracted from our textured mesh to give us some trees, and then change the symbology to the thematic trees within the 3D base maps. Kind of give a little bit more style on that. And then we'll turn on that flood layer. And essentially what this is going to do is going to give you the general idea of what this community would look like if there was a flooding event out of that river, what infrastructure would be impacted, what roads would be impacted, and help the community plan for that. And with that being said, that is the last portion of the webinar. That's all I have to show. So we'll go into Q&A.
Excellent. So folks, you have an opportunity to type in your questions at any time. And we'll go ahead and get started with a few. How often are the AI layers updated, Tim?
So our AI layers are going to be updated on each individual vertical capture. So as long as that we have ortho imagery in the area and we've already pre-processed the AI, the next time that we fly the area, you'll have the corresponding AI captured. So we generally capture 1 to 3 times throughout the US, and that's going to depend on the population in the area. So it could be updated on an annual basis, biannually, or even 3 times.
Wonderful. Does Nearmap have LiDAR capabilities?
So Nearmap is just a 3-band camera system, so it's just RGB. All of our post-processing is done through photogrammetry. So we're just using all of our stereo pairs off of our source imagery, stitching those together to create our panorama views as well as our 3D products.
Very good. And I know that you had that nice list of connecting softwares, and maybe we can revisit that. This person wants to know if you integrate these layers with Autodesk or Bentley.
Yes, so you can actually pull these layers into as shape files directly into, say, Civil 3D or Open Roads. They work along with all of our 3D stack and our 2D stuff you can bring into Autodesk or Bentley very easily.
And someone would like to know about the pricing structure. Of course, always a very popular question.
Always, right? Yeah, so it is set up as a software as a service. So we're based on annual subscriptions, and it's going off of the data model. So it's not seat-based, which is nice. So you don't have to buy one, and then that one person only has access. Your whole entire organization can have access to it within one license.
Good. And someone's wanting to know about cases you see this being used outside of the government space.
Probably the biggest one I see is either community planning or I would say within the architecture realm when you're building models and you're presenting that to stakeholders or obviously the people with the money, you got to convince them everything looks good. So I would say probably within the engineering space, preliminary design and any stakeholders communications with the community.
Cool.
All right. It looks like we got some questions in the chat as well.
Mm-hmm. Got a few more coming in, yeah.
So how accurate are the building footprints? So the accuracies of the building footprints are going to be down to the accuracy of our imagery. So our imagery is going to be from that 2.2 inch GSD down to that 2.8 inch GSD. So our building footprints are going to correspond to those nicely. All right. Do you have to pay for the ESRI 3D base maps? I do believe there are some credits that you will need to purchase prior, but I do know that there are some processing that you can do within the ESRI 3D base maps without having to purchase anything. I do think the one constraint is the level of licenses that you have within your organization. Can you use the AI to find vegetation in a small area, such as 5 feet? So we have vegetation layers for our AI. We were set up into 3 different tiers. It's going to be a medium high, so that's signifying any vegetation that's over 2 meters high. Then we have a low vegetation layer, so that's going to be anything below that 2 meter threshold, down to our very low, which is 0.5 meter and below. We also do long grass and surfaces. So usually long grass and very low vegetation kind of coincide with each other. We do not have any coverage in the UK. Currently, it's just Australia, Canada, New Zealand, and the US. There are talks about making the jump over the Atlantic, but as to when that happens, I don't know which area would be first on our list. What is the resolution of the surface model used to process the Nearmap aerial imagery? So it all generates off of our 6-inch resolution of the textured mesh. So that DSM is going to come in at that 6-inch resolution as well. Do those veg layers cost extra over the AI cost? So the way our AI is priced, they're set up as packs. So as you set up a subscription, then the AI would be an additional kind of tier that you would buy into. And depending on which pack you'd want, whether it be surfaces or vegetation, building footprints, et cetera, then that's how that pricing would go. What is the difference between the 3D building vectors and the 3D building layers extruded from 2D that you built here in the demo with ArcGIS just now? So the 3D building vectors, one, it's going to have all the building attributes already tied to that individual 2D vector. And then combining it with our DSM and DEM, you're going to be able to have the correct roof geometries and how they're segmented throughout that space. Versus the 3D building layers extruded 2D, you won't have that accuracy tied to it. That looks like that's all of them.
And I've got one more over here. What makes Nearmap so different from other aerial imagery providers?
That's a good one. I would say it is our frequency of capture. We capture on a per active basis throughout the US. That's Canada, New Zealand, and Australia as well. So it's not something that we're contracted out to do per se, that we go to these areas, fly them on our own dime per se, and distribute it to the masses. So we're going to fly these areas 1 to 3 times a year, and it's going to be updated and given to you via the cloud, so you don't have to host any imagery on your own servers. So I would say it's the ease of access and the frequency at which we capture, and obviously the high resolution that goes into it.
Wonderful.
I would just like to say thanks for joining, and keep a looking on the email that should come after this, and links over to Nearmap.
All right, great. Thanks so much. Well, thanks everyone for attending today. Thanks again to Tim, and shout out to Kayla, who's always helping with logistics. We appreciate her as well. Have a great day. Tell a friend about Nearmap and Directions Magazine. Thanks, everybody.